Okay, in this video, we are going to look at applications of using central limit theorem. So here we got the distribution of the amount of money that men spend on gifts on Valentine's Day has a population mean of $124 and standard deviation of $36. First, you need to know central limit theorem. So that should be written on your note card. I will ask you that for sure, for sure. What the central limit theorem says is that for large enough samples, even if the original data does not have normal distribution, the distribution of the sample mean is approximately normal. So this is going to be for large enough samples, the distribution of the sample mean is approximately normal. Now, these first two choices would be a typical mistake, but one thing I could tell you is the population mean does not have a distribution, but because population has only one mean. So you cannot have a distribution, so these don't make any sense. Okay, so now let's look at part B, which says what is the mean of the sample mean? So the formula that you will have available on the test, you do not need to put it on your card, is that mu of x bar is mu. Okay, so it's the same thing as the original mean, and the original mean was 124, right? That's what it was, and that's what's going to be here, the 124. Okay, so let's put that in here. What about the standard deviation? So this is going to be, again, because we're talking about the mean of 19 people, this is not going to be just 36. Again, very common mistake is to put 36 and ignore that square root. I don't know how people don't see that, but they don't. So divide, you want the division, and then square root, and then whatever is n. N is how many people you have. That should be an integer, 19. Okay, now this is asking exactly the same thing, but for 41. So we're just going to repeat. So 36 divided by square root of 41 there. Okay, so it's the same thing. All right, so now let's see if we can answer the questions, and we have to be very careful whether we can or cannot answer a question. So remember, if you're using the rule of thumb, it only works for 30 or higher when the number of people or individuals in the sample is at least 30. Then you can use the normal model, provided they didn't tell you that the original distribution is normal. If they did tell you that, then you can use it all the time, but they did not. They just said what the mean was and the standard deviation was, but they didn't mention anything about, symmetric bell shape. We don't know anything like that. So if it says, what's the probability that the amount of money spent on Valentine's Day by 19 randomly selected men is greater than 120.8? Well, the problem with that is 19 is not 30 or higher. What that means is that you should put D and E in this blank. Does not exist. It's just not meaningful. All right, the next question says, what about 41 is greater than 120.8? Okay, so here, this is probability that the money spent on gifts by 41 randomly selected men. Well, that's fine. We can do that because 41 is greater than 30. So let's go ahead and do that. So let's go to Desmos calculator again. Let's go to plus sign, inference, probability distribution, normal. Okay, now we're talking about 41 men, not one person. So the mean here is 124, but again, the standard deviation is not 36. It's going to be 36 divided by square root. So use the square root from the toolbar, 41. Okay, and then create distribution, expand the cumulative probability. We want greater than, so that's right. And then we're going to type 120.8 in the blank. So that's going to give us 0.715. Okay, great. The last question says, what is the probability that the amount of money spent on gifts for one randomly selected man is greater than 120.8? Now, can we use the normal model for one person? Did they tell us whether the original distribution is normal? No, they did not. So we cannot do anything here. We cannot use central limit theorem. This is not the mean. This is just one person. So this is D and E also.